in 6.4 rectangles. First thing I need to know is, what am I asked to prove? My given statement. I'm given that ABDE is a rectangle. So 1. ABDE is a rectangle that's given. Now, I don't have anything else really that I can do as far as, overlapping sides or vertical angles. But what I can do is I can look back at that given statement, and there's a key vocabulary word there, rectangle. What does it mean to be a rectangle? Well, if it's a rectangle, that means that it is, if I go back to my definition, a parallelogram with 4 right angles. So earlier on today, we defined a rectangle as a parallelogram with 4 right angles. So my second step, I should say that angle A, angle B, angle C, angle D are right angles. And that's by the definition of rectangle. So let me mark those in. Mark this in, mark this in. Now, let me go back to the idea that it's a parallelogram. If it's a rectangle, by definition, that definition we wrote down earlier, it says that is a parallelogram with 4 right angles. Well, if it's a parallelogram, then it has some properties that we know from earlier. And those properties that we talked about last week are, it has opposite sides that are equal, it has opposite angles that are equal, it has consecutive angles that add to 180, and the diagonals bisect each other. So if it has those properties, we already have the opposite angles are congruent and the consecutive angles add to 180. That's already marked in there from the right angles. I also don't really have any diagonals drawn in here, but what I do have are opposite sides that are equal. So I could say that AE is congruent to BD, and AB is congruent to, or BA is congruent to DE. BA congruent to DE. I don't know why I put 2 there again. It should be step 3. Step 3. That's because the opposite sides of a parallelogram are congruent. We learned that from earlier, whatever that theorem was. So let me mark that in. And I'm trying to prove that AC is congruent to EC. Okay, let's stop for a moment. What did we do? What was our process? We first did our givens. Then we did the definition of what it means to be a rectangle. And then we thought about the other properties that a rectangle might have. Does it have opposite sides are congruent? Does it have consecutive angles that add up to 180? Does it have congruent diagonals? Right? So we were given these things that we could have used because it is a rectangle. That's in the given statement. Now I'm trying to prove congruent parts. I'm trying to prove that these 2 parts are congruent. Well, what I'd like you to notice here is that I have two triangles. And I would like to prove that those triangles are congruent. So looking at the top triangle, ABC, I need to prove that this is congruent by something, right? Side, 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 or side, angle, side, or angle, or angle, angle, side, or hypotenuse, leg, even. It looks like on that top triangle I have two sides and the included angle. And on this bottom triangle I also have two sides and the included angle. So I have two congruent triangles here. But how does that help me? How does it help me to have congruent triangles? Well, now if I have congruent triangles, what I can do is I can claim that because the triangles are congruent, all of those matching parts have to be congruent. I was asked to prove that AC and EC were congruent. That's this side and this matching side from the other triangle, the corresponding parts. So because I have congruent triangles, then I can say that AC is congruent to EC because corresponding parts of congruent triangles are congruent. Please let me know what other questions I can help you with, and I will see you tomorrow.